the diameter is equal to 2 times the radius. You've probably seen that already when you were doing geometry. And if we were to visually interpret it, it's just basically saying that a diameter is equal to 2 radii. Okay? And if we were to put it as an equation, it's basically saying d is equal to 2r. So once we know the radius of a circle, then basically we can plug it into the formula to get the diameter. But what if I wanted to figure out what the radius is if I knew the diameter? Could I come up with a formula to always know what that would be? Well, if I look at what I have here, then you'll notice that 2 r's give me a diameter. So 1 r alone must be equal to a half of the diameter. Okay? Based on what we're seeing here. And if we think about it, that makes sense, because if d is equal to 2r and I wanted to solve for r, I wanted r by itself, then if I divided both sides by 2, I'd get r, and that would be equal to d over 2, or half of d. Now when this happens, we say that we have made r the subject of the equation. Remember, in English, whenever we say that something is the subject of a sentence, it's the thing that that sentence is about. Well, in math, equations have subjects. The subject is the variable that's the focus of the equation. In this case, it would be r. Simply put, it's the variable by itself on one side of the equal sign. So for example, if I had an equation like x equal m plus y, could you tell me what the subject is? Well, you're seeing here that I have x by itself here, so x is the subject of the equation. But if I gave you another equation like x equals m plus 2x, is x still the subject of this equation? No, it wouldn't be, because I have x on this side and I have an x on that side. Whenever we make something the subject of an equation, it has to be by itself on one side of the equal sign. So we can't have a part of it here and a part of it over there. Now we can rearrange formulas like this one and others to make different things the subject of the equation. So let's say we had another formula. For example, let's say that we had y being equal to 2x plus c, where as you can see here, y is the subject. If I wanted to make c the subject, okay, then the whole idea is to get c by itself on one side of the equal sign. So I'm going to write it like this, just to make it a little clearer as we work. Put it on the left hand side. You can follow it more logically from there. And if I were to even draw it, what it's really saying is that my y, okay, is equal to 2 x's and a c. That's visually what it would look like. So if I want c by itself, okay, that means I would want this little piece right here. I would just want a c by itself. I would want to make c alone. And that little piece is the same thing as all of y, take away these 2 x's. So really what I have here is c is equal to y minus 2x. Because if you think about it, that's what this is saying. This is saying that I'm taking my 2 x's from all of y to give me that little piece of c. So that's how I would solve for c. And that's what it probably would look like. You know what I mean? Now, what if I wanted to make x the subject of this equation? What would that look like? Let me come over a little bit here. And if I were to make, let me use a different color. If I were to make x the subject, okay, then visually we can think about it as saying we have our y, and that's equal to 2 x's and a c. So if I want one of these x's, first you'll notice that 2 of the x's is equal to this section. What's this section? Y minus c, because it's like all of y, take away this little part of c. So y minus c would be the same thing as these 2 x's. And if that's true, that means if 2 of these x's is y minus c, then one of the x's must be a half of that. So it must be this little section, a half of y minus c. So we can use this to conclude that x is the same thing as a half of y minus c. So drawing it kind of helps us to interpret what it's look like, what's going on in the equation. But sometimes when we get more complicated equations, drawing it doesn't necessarily help. We can still treat it in the same way that we do when solving equations. Let's see what that looks like in this next example. So let's say I wanted to make t the subject of this equation, d equals v over t, okay? So if I'm making t the subject, that just means I'm trying to get t by itself. The problem here though is that t is in the denominator, and if I'm going to make t the subject, I'm going to have it by itself. In other words, at the end of the day, I'm going to have t equal something. So I need to get t out of the denominator. If I multiply both sides by t, then that means d times t is going to be equal to v, right? And now that t is no longer in the denominator, what would you do next to get t by itself? That's right, we would divide by d because we need to get rid of that d. So that means t, if I divide both sides by d, t is going to be equal to v over d. And now, well, I can rub out what I had down here because this is what the answer is. T is equal to v over d. In the next equation, we want to make m the subject of I equals mv minus mu. So let me just write that down right here. And in this equation, now we have m in both of these terms, but we want to make m the subject. So that means we're going to need only one m. What am I going to do next? Well, here is where factorization would probably come in handy, right? Because if m is a common factor between both, then if I factor out m, okay, then m into mv would just be v, and m into negative mu would just be negative u. And now I have one m by itself. Oh, that m doesn't look good, but I have one of the m's by itself. I should stop playing with it. I have one m by itself, and now I need to make it the subject. Since m is multiplying v minus u, then if I divide both sides by v minus u, right, then v minus u will cancel on the side that m is, and that would just leave me with I over v minus u is equal to m. Or I could rewrite it with m at the left-hand side of the equation. So that's how we can transpose some equations. Changing the subject of an equation is something that I guarantee you're going to see again. So I really want to make sure that you're comfortable doing it. So after this video, I'm going to give you a few to do on your own, and then there will be a video discussing the solutions to those. So go ahead and give them a try.